In our next problem, we're given 4 parallel current carrying wires. This current is coming up out of the page, this one's coming up out of the page, this is going into the page, this is going into the page. I've already written a little bit down that we'll need. When we're given the problem, it just looks like this, something like that. We're told that the sides are 0.2 meters, right? This is 0.2 meters. So I went ahead and I started to find the value from any of the corners to r, because this is a square, so they should all be the same, so this distance will be useful later. We're told that we want to find the value of the B field, the cumulative B field at point P. Okay, so how did I find r? I just used trig. R squared is equal to x squared plus y squared. So those are both, and they're obviously, if they're the same, then we'd have 2 times something like this. Okay, which means that r is equal to the square root of all that. Okay, which I ended up getting 0.14 meters. All right, next we can find the magnitude. Since these currents, we're told these currents are all the same, right? And they're all the same distance away. They're just going to be pointed in different directions, and so that's going to give us something unique at the end. But what we can find right now is just the overall magnitude of each of the B fields from each wire. Those will all be the same. So the magnitude is going to be mu naught over 2 pi times I over r. Right? We just found r. We're given I. We know this value and this value, so we can just plug those in. And then I ended up with a value of 7.14 microtesla. So this is just the overall magnitude of each of these wires for the B field, of the B field coming from each of these wires. Okay, and so now we're going to have to consider the direction of each of the B fields and sum them up at the end. So I've drawn a diagram here. Let's take a look. So over here at A, we've got the current going into the page. So if we point our right thumb along this current into the page and curl our fingers around, we end up with a B field going in this direction, right? So I've drawn that out. So because it's forming a circle here, it's going to be going at point P, it's going to be, we could say 45 degrees down, or if this is the horizontal, this would be 135 degrees from here, which is the same. So I mean, if we have sine 135, that's going to give us the same value as sine 45. And since these are negative, we're going to end up with sine negative 135 here, or sine negative 45 here. It's going to give us negative square root of 2 over 2. That'll be useful in a little bit. Okay, and so pretty much just doing the exact same thing that we did for this one. Over here, we're going to point our right thumb out of the page along the current and curl our fingers around. It's going to give us a magnetic field going in this direction. And then so at point P, it's going to be 45 degrees downwards. So that's negative 45 degrees. It's going to give you the same thing. Over here, similar process. It's going this way. So the B field is going to be pointing down again 45 degrees at point P, and then we do the same thing over here, and again we find that it's down 45 degrees at point P. So if we look here, we take the B fields in component form, and this B field is pointing exactly opposite of this B field in the x direction, so those are going to cancel. This B field is pointing exactly opposite of this B field in the x direction. Those are going to cancel. And then we're just going to be left with the y direction. And so because they are the same angle, we're going to have, and they're all going in negative y hat direction, right? This is down in the y hat direction, down in the y, down y, down y, and it's all, so now we have something that looks like this, right? Let's see, what was the times the b, right? So times b field. And negative y hat, well, we have negative y hat direction from the angle. So this is y hat. So this is going to give us a value, just double checking my work here. So 4 times 7.14 microtesla times square root of 2 over 2 in the negative y hat direction. 20.195 microtesla negative y hat, or 20.2 microtesla in the negative y hat direction. That's the net B field.